Hello, Year 12, and you join us today on the last YouTube video I'm going to be uploading. I've been requested to migrate the maths department away from YouTube to Microsoft Stream to be in line with the rest of the school. It's a bit like getting out of your Porsche and getting into a Vauxhall Astra, but there we go. That's progress. So I mean, from your point of view, nothing will change. You'll still get links to videos. They'll just be on Stream rather than YouTube. I'm sure it won't be a problem. I just won't get the hits anymore. A reminder that after today's lesson, between 1:40 and 2:20, I've set up the first of our Teams clinics. So that's entirely optional, but you know, if questions have cropped up since we met together on Monday or Tuesday, then that would be an excellent opportunity to do to address them. I've also set a new homework due next Wednesday, so you know, it may be that you have a quick look at that after the lesson and address some questions in that homework. Don't forget, I'm always available on email, and you know, I'm very happy to knock up work solutions or little video solutions to help you. So yeah, this isn't replacing that. Okay, so here is one of the independent study questions from the last lesson. Don't forget, you've got a regular submission question from last lesson, which I'm not going to go through this lesson. I'm going to mark in OneNote. So this is one of those binomial within a binomial questions. So it starts off pretty conventionally. Binomial where you're doing something 20 times and your probability of success is 0.6. So these are our parameters. And at least 50% means 10 or more, doesn't it? So I put lower of 10, upper of 20, and that's the answer I got. So that was one sort of session of archery, 20 arrows. We're then told that she does that 12 times. So now this is a classic binomial within a binomial. The number of times she's doing something has changed. She's repeating what the first part was about 12 times. And this time, success is that she hits the bullseye with at least 50% of her arrows in a set of 20. And so our probability of success is the answer to the previous question. So this is the binomial, or these are the binomial parameters for parts B and C. For part B, so I entered n is 12 and that is my probability. Upper and lower of 7 gave me that, and fewer than 6, that's lower of 0 and upper of 5. And it gives you a tiny probability, and you know, I guess you were quite justified in saying, well, shouldn't I have written it like that? I'm a bit of a belt and braces man, so I probably would have written it like that. But I think we've got a classic case here of a textbook question rather than an exam paper question. An exam paper question, they would be much more careful about telling you how to answer. So that was that question. Hopefully you had a go at that. You know, the secret to success has not changed during this period. Practice, practice, practice. Okay, and I know many of you will have gone straight to that question after the video and had a go at it. And you know, if you didn't get the same answers as me, why not drop me an email, or why not pop in to my little Teams meeting tomorrow? I really care very little about whether cameras are on or off, so please don't be anxious about that. Right, my camera will be on. So there we go. Okay, so I'm going to finish binomial now. As I said in the last video, I'm a bit anxious that we started really easy, and then we got onto some really tricky stuff. The vast majority of binomial questions you will get in an exam are basic ones, like this one here. Okay, so this comes from a set of practice questions the exam board produced. So go on, just pause the video, have a go at that question. You have only got one probability to find out, and there's no need to state any assumptions, so just have a go. Okay, so hopefully you were able to state your parameters, and this means from 5 up to but not including 11, so hopefully you used lower of 5, upper of 10, and that was the probability when rounded to 4 decimal places. Okay, So if you could do that, you're going to be able to answer the majority of binomial questions. The inverse binomial, binomial within a binomial, they crop up every now and then, but they are never the whole question. You've always got simple bits like this to start with. Right, let's move on. We're actually going to go backwards in statistics because we skipped a chapter on probability, and that's because it's stuff we can really do already. So we are going to whiz through the content of that chapter, safe in the knowledge that actually I'm not going to have to teach you a great deal that you haven't come across before. Okay, so here is a probability question. It's a good probability question because it combines a little bit of interpolation from the previous work we did in statistics. This is not binomial, this is not overcomplicated, this is just, you've got 140 dogs and we are choosing one at random. So we know the answers to these questions are going to be fractions out of 140. And hopefully you'll be able to get these two quite easily from the table. All right, I'm going to give you a moment to do that in a minute. For this last question, I can always remember doing this and getting really mixed up. This sentence here is telling us about a different breed. So we sort of almost come to that bit at the end. We're talking here about bull mastiffs. So to start with answering part C, work out the probability the mass is less than 53. Now you'll see that doesn't line up nicely with the groups, which is where the interpolation comes in. So yeah, pause, see if you can get those two answers and this part as a start towards the answer to that question. Okay, hopefully you're all right with that. So less than 54 greater than 54 is these last three groups added together, so 56 out of 140. 48 to 57 are these three groups added together out of 140. Why haven't I put an extra line here? Well, because we've now gone from discrete data to this is continuous data. So actually, you know, we know with groups data we're unlikely to get a dog that weighs exactly 54 kilograms on the nose. So you know, it doesn't actually matter. So a probability that the mass is less than 53. So that's all of those dogs and all of those dogs and some of these dogs. Now, this goes from 51 to 54. So that's got a width of 3. A width of 3. 53 would be 2/3 of the way into that group, wouldn't it? Because 53 is 2 away from 51. So it's 2/3 of 42 would be less than 53. We'll come to the assumption we've made in order for that to be true in a moment. I'm sure you can see where we're going with that. So that's 28 dogs. So I've got my 17 in the first group, I've got the 25 in the second group, and then I've got 28 dogs from the third group. That's a nice easy answer. So let's firstly answer this question. A Rottweiler chosen at random has a mass under 53 kilograms of that. So it is less likely that a bull mastiff will. This is about bull mastiffs. Less likely. The assumption we've made, well, this is always the assumption you make with grouped data, and that's that the 42 dogs in this group are evenly distributed between 51 and up to, but not including 54 kilograms. Okay, in the independent study at the end, there's another example of that for you to try. Here's another chance to revise something from before. This is a probability question that involves histograms. Now, if you remember, it was all easy at GCSE. The area of the bars was equal to the frequencies. At A-level, it's slightly more confusing because the area of the bar is proportional to the frequencies, so there might be a multiplier involved. We've got 70 cats represented by this diagram. So my first job is going to be to work out the area of these bars, work out what the area adds up to, and then just see what the relationship between the area and the frequency is. Now, you might be thinking, that chart isn't big enough for me to try, for me to work with. Hello! So I've attached a handout with a big version. If you want to print it, you can, or you could pause the video at this point, because I'm going to be working on this one. And yeah, come back when you've worked out the total area of the histogram. Okay, I started off by misreading the axes, but I think I got there in the end. And to my relief, the area does actually add up to 70. So this is a straightforward question where, you know, 1 unit of area does actually equal one, I forgot what we're dealing with here, 1 cat. Okay, right. But don't always assume that. Don't assume that. So find the probability that a cat chosen at random has a mass of more than 5 kilograms. So that is those two bars added together. So that's 24 cats in that one and 8 cats in that one. So that's 32. Don't forget it's a probability, so it's 32 out of 70. And so that's 16 out of 35. Go on, see if you can do the last question. Pause and have a go. So this last bar represented 8 cats. If you remember, we worked that out. 8 cats. And we were told to think about 6.5. So what I did was I worked out how many cats were more than 6.5, and it's 3/4 of that bar, isn't it? 3/4 of that bar, so it's 6 cats. 70 cats altogether, so the number of cats less than 6.5, remembering with continuous data, we're just saying it's completely impossible that there'd be a cat that's exactly 6.5. You know, no grams, no milligrams or anything like that. So 6 cats that are more, so the number of cats that are less will be 64. That's 64 out of 70. 32 out of 35. You could change those to decimals, but there is no need to do that. Independent study at the end has a histogram question. Okay, last question for today then, Venn diagram question. Again, something we've done before. If you can't see this clearly on the screen, it's page 74 on the stats book, question 2. And on the same handout that I gave you, that histogram, there are 2 empty Venn diagrams just to help you out. There's an independent study question on this as well. And it helps if we all do the same. So I've done my circles like this, and I've got garlic bread, beer, and cheesecake, that well-known combo. So I'm going to leave you to run with this. I will just say one thing. I think it's easy to start in the middle and work out. And so, you know, that's where we start. Those people who ordered garlic bread and beer, 25 of them, remember that includes the 15 that had all 3. Okay, so I think that's probably where people most often make mistakes with this. That 25 there is everyone in that overlap between garlic bread and beer. So that means you just got 10 there. So go on, see if you can fill in the Venn diagram, and then you've got 4 straightforward questions, all of which are going to be probabilities out of 125. Okay, have a go. Okay, so I've filled in my numbers. Got a bit confused, but worked out what I've gone wrong in the end. Have I finished? Well, hopefully you can see that I haven't. If I add up all of these numbers, and I did that by saying, right, 43 are garlic bread, so all those numbers add up to 43, and then just add 10 plus 5 plus 13. That only comes to 71 people. And the question starts by saying there are 125 diners. So we've got a missing 54, and they're the people who are outside. So always remember to check the outsiders. So all 3 items, and I'm assuming you can cancel these, so I'm not going to cancel them. Beer, but not cheesecake and not garlic bread, so that's these 10 people. Garlic bread and beer, but not cheesecake, so that's those 10 people. And none of these items, 54. And the question doesn't say how many people, it says what's the probability. So we've got to make sure we are giving that as a fraction out of 125. There are two sorts of Venn diagram we meet. There are ones like this where you put the number of people, but we also are sometimes asked to put the probability in. So, this is 7 out of 125. This is 10 out of 125. And it's probably more likely that you will see those sorts of Venn diagrams at A level. Anyway, there is another one of that sort in the independent study questions. And while we're talking about independent study questions, there are 3 for you to try. This is in the stats book, obviously, and hopefully you've got one of the frequency distributions, one of the histograms, and one of the Venn diagrams. Venn diagrams we're going to linger on a little bit because there is some new stuff relating to Venn diagrams. Then we've got tree diagrams, which are definitely not new, and then that's it for probability. And then we'll leave stats and we'll go back to some pure. So we will be back on pure maths before the end of next week. Okay, look forward to seeing some of you in a minute on the live lesson. I know it's not in a minute. It depends on which group you're in. But anyway, it's the same time. It's one clinic for both groups. And don't forget, homework is due next Wednesday. And don't forget, some of you still haven't submitted your individual question from last lesson. No individual question from this lesson. And have a lovely weekend.